Hello, I welcome you all in the class of electromagnetic waves and transmission line. Here, name itself is what? Vector algebra. So, how this vector quantity is going to perform the algebraic operation that we are going to discuss here. Since it is related to uh, electromagnetic waves, so that electromagnetic name is what? Electromagnetic. So it has combination of both electric field and magnetic field. Both phenomena is included in this. That's why it is called as the electromagnetic. So when we see that in case of later we will have electrostatics. So where we have charge at rest and sometimes again we have charge in the motion that we are going to see. So in case of electromagnetic, if you see that when wave is going to propagate, suppose here we are considering that wave is propagating along the z direction. So in that situation, what is the propagation of electric field and what is the direction of the propagation of the magnetic field? So suppose this is going to represent the electric field components. So this is our electric field. Now we'll have to represent the magnetic field components on this. So this magnetic field components will be perpendicular to the electric field. So here we have to imagine, okay. So this H, this is also H. So we are using the different colors for the understanding purpose. So electric field and magnetic field both are perpendicular to each other, as well as these both are perpendicular to the direction of propagation. Okay, so that is the electromagnetic field. So it has various applications. Whether if you talk about microwave engineering, if you talk about antenna, in satellite communication, in case of biomedicals, like we have nowadays we are using the MRI, magnetic resonance imaging. Like this, it has various applications. So it has different range of the frequencies. That range of the frequency is going to change from hertz to the many gigahertz. So that wavelength is also going to change from the nanometer to some meter, kilometer like this. So it has very broad perspective is there. So in this vector algebra, first we need to understand what is the scalar. So from your school days, already you know about this. What is the scalar quantity? Yes. So a scalar means it has only magnitude. It doesn't have any direction. So like for example, we'll have speed. Okay. You can give some other example of this. What's another example? Can you write distance? Okay. So it has only magnitude, no direction. So that we call as the scalar quantity. Whereas vector quantity means it has what? What are things? Can you recall that? So vector quantity means it has magnitude and what other things? Magnitude as well as direction. That we call as the vector quantity. So like example of this, what we can call like velocity and displacement. These are the common examples that you are familiar with this. And another term, always we are going to talk about field, electric field, magnetic field, all these things. So what is the field? Okay. So again, field is the function of some particular quantity that is available everywhere in that region. That we call as the field. Like we have electric field, magnetic field. So these are the function, okay, of particular quantity that we call as the field here. Okay, it is the function. Like this, we are going to see here. So continuation of this, we have another term we call as the unit vector. So unit vector is also very important in case of here in electromagnetics. So many places we are going to use here. So we are going to define the unit vector. So name itself is what? Unit vector. So what you can guess why it is called as the unit vector? Anyone of you can guess about this, why it is called as the unit vectors? So it has magnitude as 1. It has magnitude as 1. That's why it is called as the unit vector. So now suppose, for example, A is the any vector. For that, we have to find the unit vector. So that unit vector is represented by A. Okay. So for vector capital A, we are trying to find. So we can put the suffix here, that is subscript here, A. So that is defined as the vector A divided by magnitude of the vector A. So that will give us the unit vectors. Suppose, for example, if later we are going to discuss about coordinate system, or here suppose we'll consider vector A as in the Cartesian coordinates as Ax, and we have another components that we can write here. This is I plus Ay along the y direction plus Az along the z direction. So finally for this, if you try to find the magnitude, so magnitude of this will be root under Ax square plus Ay square plus Az square. So in this case, if you have to find the unit vector, so that unit vector will be written as that vector A, that is we have Ax, I, here we can write a small ax also, Ay, j plus Az, k, and divide by magnitude of A. So magnitude of A is what? Ax squared plus A squared plus Az squared. So like this, we are able to define the unit vectors. So this vector, we are going to see that whether they have similar properties when we are going for the addition or subtraction of the two vectors. So that also we can see. So addition and subtraction of the vectors. So from the earlier stage, if you see that you will have a discussion about 3 different laws. Okay. So that is applicable in the Boolean algebra also. So that law we call as the, what is the law? Commutative law. Commutative law. So here if you're going to add two vectors, suppose we have one vector as the A, another vector is the B. So A plus B will give same value as the B plus A. Similarly, if we'll have another law we call as associative law. So in associative law, if you'll see that this is about the association. Now suppose we'll have three vector A, B, C, and here B and C is associated together. This also can be written here like this. A plus B will be associated together plus C. And another we have distributive law. So this distributive law name is what? Distributive. So we'll see that how this distributive law is going to work. So now if it is a vector A plus B is multiplied by K, this one we can write Ka plus Kb. So this is called as the distributive law. So like we have three different laws are here. So in case of addition, these laws are applicable. Okay. Another, we have discussion that we call as the position vector. So position vector means it's going to represent some particular position. Suppose, for example, any idea what is the position vector? So in the initial stage, we consider the Cartesian coordinates. Okay. So here, suppose this is x, y, z. Now some point P we are going to consider in this here. Okay. And here we have origin. So what is the position of point P with respect to origin? Okay. So this vector is what our position vectors, and P will have some coordinates, suppose x1, y1, z1. So this vector will represent the position of the point P that we can write here. Okay. Another term we have, or this one, suppose you are going to give the name as the R. So this R will be represented here. We can write R position vector as x1 ax plus y1 ay plus z1 az. This is the position vector for the R. Similarly, we have another term we call as the distance vector. So this distance vector, we wish to find what? The name is what? Distance. So we are trying to find the distance between two positions. Okay. And that position is being represented how? These positions are represented with the help of vector only. Okay. So now suppose we are going to consider 2 points here. Okay. So this one we can name as suppose P. Okay. So for this position vector, we have to denote. Okay. And this coordinate, suppose we are going to take as x1, y1, z1. And we are going to take the another point. Okay. Another position. Suppose this is the Q. For this, we are taking x2, y2, z2. Now, what is the position here? Okay. So this is the one vector and this is the another one vector. Now, finally, if you have to find the distance between P and Q. So all this distance we are going to find between P and Q. So that is given by the help of here distance vector. So the distance between these 2 points P and Q we can write as, so x2 minus x1. Okay. And this is the x component. So ax unit vector plus y2 minus y1. Again ay plus z2 minus z1 az. Like this, we are able to find the distance between two positions. So here we have discussion about vector algebra and some basic properties that we have seen how we are able to find. Okay.